Imagine pulling data from an external API, cleaning the text, training a machine learning model, and sending out a final report. Managing interdependent steps like this manually requires rigid scheduling and constant supervision. If one step breaks in the middle of the night, the entire downstream pipeline often fails silently, leaving you to untangle the mess the next morning. Apache Airflow eliminates this manual oversight. It acts as an automated orchestrator, scheduling tasks, triggering automatic retries upon failure, and providing a visual dashboard to monitor the exact status of your entire workflow. This illustrates the directed acyclic graph, or DAG. Tasks are nodes. Execution flows forward, never looping back. To run this, Airflow relies on 4 pillars: web server, executor, metadata DB, and the scheduler determines when tasks execute. You write these pipelines entirely in Python. Once you define a basic 3-step sequential process in your script, Airflow instantly translates that code into a clear visual map in your browser. By defining your infrastructure as visual acyclic code, you can pinpoint the exact moment a specific task fails. Complex data pipelines become fully transparent, predictable processes. Using the bit shift operator, a simple line of text compiles into a rigid dependency graph. As tasks run, they share context through XCOMs, or cross-communications. A completed task pushes state data forward, and the next task pulls it to proceed. You must restrict XCOMs strictly to small metadata, like file paths or unique IDs. Pushing massive data files directly through an XCOM will overwhelm the metadata database and crash your instance. This comparison illustrates the evolution of how we write these pipelines. On the left is the legacy approach, reliant on dense boilerplate code. On the right is the 2026 standard, the TaskFlow API. By adding the @task decorator above a Python function, your pipeline behaves like native Python code. The TaskFlow API handles the underlying architecture, while you write the logic. It automatically generates and routes XCOM connections for you based on your function's inputs and outputs. Upgrading to the TaskFlow syntax strips away brittle boilerplate code. It reduces the risk of passing the wrong data, letting you focus entirely on transformation logic. A sensor pauses your pipeline passively, waiting for an external event, like a file arriving in an S3 bucket, to wake the node. Then the pipeline evaluates the data and uses branching to route it down one path, entirely skipping the irrelevant path. Let's put this into practice. Pause the video here. Using a blank document, write the basic structure for a 3-step daily pipeline: extract, check quality, and load, using the TaskFlow API decorator. Make sure to define your Python functions, and at the very bottom, write the precise line of code to set the execution order. This image shows the correct structure you should have written. You have 3 distinct Python functions declared with the decorator, and the critical bit shift sequence at the bottom to lock in the execution path. Integrating sensors and branching into your code converts a static schedule into a highly reactive workflow. Your pipelines can now wait patiently and make intelligent conditional decisions the moment new data arrives. Moving to enterprise scale, the KubernetesExecutor assigns every task its own isolated pod, spinning up compute resources as needed. With dynamic task mapping, a task hitting massive data scales dynamically, creating dozens of parallel pods to process the load simultaneously. To safely operate at this scale, every single task must be idempotent. This means whether a task runs exactly once or is retried 100 times due to network errors, the final data state remains exactly the same. You must also keep all heavy processing logic strictly inside your task functions, not floating at the top level of your DAG file. The scheduler parses every DAG file continuously. Putting expensive code at the top level will bottleneck the entire system. Your definitive production checklist: make tasks idempotent, keep DAG files light, use the TaskFlow API, never pass datasets through XCOMs. Screenshot this list. Adhering to these patterns ensures your pipelines remain predictable even as you scale to thousands of daily tasks. Download the official Airflow Docker Compose file from the description, spin up your local environment, and start building.